Alright, we are going to be engraving, deep engraving specifically on glass using the L-Cheapo Mk7. This is still one of the prototypes, and this is finally the production version. We have done a closed beta for a few months. Now I'm ready to release this to the public. It will wire up exactly the same way as the Mark 6. You can see the usual text hexagon right here, and we're going to be burning another one. Now, this is a diode laser that can do glass, which is cool, but however, there's a catch. It will take a long time, so I'm gonna do something I usually don't do and pause the video here. So let me set the Z-axis real quick. And let's go. Glass looks kind of trippy from here. So like I said, very slow movements, but it will get done. Note that there's no additives, there's no moly spray, there's no stuff that you put on the glass. And this is nice and thick window glass. It's kind of cool like this actually. So of course you can also do, you can also do point engraving. You can, do a little pointillist artwork. And I'm going to pause the video now because this is going to take a few minutes. I apologize for how loud this thing is, but that's just loud. So you can actually kind of sort of see the new hexagon taking shape. So the camera is kind of barely picking it up. And the trick here is that we're going to go over that a few times, just to make sure that the engraving happens the way it should. In this specific case, we're going to go over it 6 times. It's probably overkill, frankly. You should be able to get a good result with only 3 passes. But, I want it to show up nicely. It's almost done with the first pass. And like I said, I'm going to pause the video now and let this thing finish, and see if I can give you an accurate timing of how long this takes. And pause. Now this is interesting. It looks like my y-axis kind of laid an egg a little bit. I'm getting a double trace. However, I want to see what it does at this point. I'm curious. This is no longer a demo video. This is a little experiment. It really has to pay for itself. Still going, so we're getting multiple traces. However, we're not here to test the printer, we're here to test the laser. So we're about 4 minutes in at this point. We're about 8 minutes in. I need to check my y-axis, clearly. But other than that, it seems to be working okay. We'll know in a minute. Talk about the loudness. So the Mark 7 is in fact louder than the Mark 6. That's just because it needs more air. There's no way around it, it's just physics. We're about 10 minutes in at this point. Looks like we're getting there. I love the light effects. It looks pretty trippy. If you look at this without the filter, it would just look really blue. So it kind of dies despite the filter. And clearly though guys, these are not toys, okay? So I haven't done a formal test yet for the Mark 7, but I think you're looking at 12 watts, as in 12 actual watts, not 12 watts peak, and then it throws itself down. I generally do not measure peak power because, frankly, peak power is actually not a good idea for a diode laser, because you get this big burst and then it throws itself down. If anything, it actually messes up the material. So L-Cheapo lasers are internally self-thermoregulating. So there should be ideally no peak power. There is a small peak when you turn it on, of course, but we're actually trying to avoid that. So if you get a Mark 4, it says 5.6 watts. I am guaranteeing you at least 5.6 watts for your whole cutting or engraving job. This is the Mark 7. It's just an evolutionary improvement of the Mark 6, really. It's just same basic electronics. Most importantly, we got a much beefier fan. What I've been doing is that I've been selling them to people who already had a Mark 5 or Mark 6 as an upgrade. The reason is that this thing's pretty beefy, and it can be dangerous, and it can set fires. So I wanted to only sell it to people who already had a laser. But I am fairly confident now that we got the interlock switch in place for this guy. So it's not going to be an issue. Now, one thing that's important is that the Mark 7 is only going to be sold with its own power supply. And the reason for that is simply that at this point most of the problems we've had with the Mark 6 is that people were hooking it up to their printer or their engraver, and it was underperforming because they were not giving it enough juice. So I figured, let me send you a known good power brick so that you may get full power from the get-go. There will be an interlock switch, which will also act as an opto-isolator so that you can put the switch on your lid if you have a lid. By the way, the reason why I don't have a lid is that normally I keep my my setup in this closet. So there will be an interlock switch, an opto-isolator, and a power brick included with the Mark 7. So all you have to do is just connect it to your either your logic PWM output or your existing laser connector. Your logic board will think that it still has the smaller laser connector, so you won't even have to do any changes on your software except probably making it go faster so that you don't cut a hole in the material that you're trying to engrave. This should be the last cycle. See here, 92%, yeah. Yeah, this guy's almost done at this point, and we're gonna see in a minute. Yeah, that was supposed to be a hexagon. It looks more like a big hexagonal splotch, but I think we can live with that. Actually, that's a good thing, because now you can easily tell the difference between the one that I did off camera and the one that I did on camera. In the meantime, so this is what the final design looks like. You can see that the board has almost the same form factor as the Mark 6. We got a beefier fan. We got somewhat beefier voltage regulators. We have resynchronized the current regulators. And as for the Mark 6, we're going to be making our printed circuit board at an aerospace rated facility in Oregon, Sentinel Circuit. When I say that my products are made in the United States, I mean that I also try whenever possible to use United States suppliers. Everybody can put a made in the US picture by just ordering a bunch of parts from China and then, putting them together in a shop locally. What we've been trying to do is do as much of the manufacturing and component sourcing domestically as we can. So there are some things we cannot do. You can no longer buy resistors made in the United States at a competitive price. We don't have them anymore. If I was wrong, there's going to be one last pass by the look of it. And we're going to see what the result of this mess is in a minute. I'm going to use a toothbrush to clean it up. Let's see if I can do that on camera. The idea here is to have a nice deep engrave, and I am speculating that I should be able to just cut smaller glass. The next demo is going to be interesting because we got one of these things to cut steel foil. You can buy a solid state laser that cuts steel. Granted, it's only a few mils of steel, but nevertheless, it's going to be the next video. The only thing is that I gotta repair this printer. This thing has been doing duty for 6 years now. I've done all my experiments on it, and the Y-axis carriage is starting to show its age. So I'm gonna have the other printer print a new carriage, and we're gonna keep this going. So by the way, for anybody wondering, this is a Solid Doodle tray. Solid Doodle is no longer in business, but you know, they made a good machine. It lasted a long time. This one has been variously modified. The carriage there survived a fire that was set by the very first L-Cheapo laser because I accidentally lit the fire. And I think this should be it. Either that's it, there's one more layer. There's one more layer. I'm kind of running out of stuff to talk about here. So in the meantime, I'd like to point out that you can go on our wiki and download the schematics and the parts list and the 3D printed part STL for this guy. Same thing for our robots, same thing for our scientists. Most of what we do is available to the public on a Creative Commons Attribution Non-Commercial Share-alike license. As always, if you want to get a commercial license, you can just send me an email and you will get an answer. If you are an educational institution, you are going to qualify for special rates on that. I may just give you a educational license just because. Anyway, looks like we're about at the end of the cycle here. It's 97%, so yeah, that's probably the end of that. And if it's not, I'm just going to call it early because this thing has been going for about 15 minutes at this point. The one thing that's interesting is that I'm going to get a completely different figure than the text hexagon. You can kind of see that, like I said, the Y-axis needs a bit of love. But let's see where we are with this. I'm going to hit reset in a minute here if it doesn't finish. Supposed to be a demo video. It actually turned into a live test, which frankly I'm kind of happy about because I don't really believe in showing, you know, super polished demo videos. Ah, there we go. Much better. And let's see what we can see here. So yeah, what we got here is a nice piece of engraving. So that's the one we did off camera, that's the one we did on camera. And I think that all the passes I did were overkill because Let's clean it up a little bit from the wood that I'm using as support. Yeah, see that? Most of these only go one pass effectively. So, and they all show. You get a nice progression here. Let me take the filter off. There we go. Take the filter off and take a good look at this thing. If you can actually see the thickness a little bit. Yeah, you can see it. So yeah, this is a nice deep carve. So yes, you can do glass with a solid state diode. Just make sure it's an L-Cheapo.